Okay, great.
Okay, so yeah, we'll get started. It's 2 o'clock here. Just towards the end of the semester, I know a couple students right here running in between things, and I don't have anything else to do right now. Sort of besides spend an hour or less listening here. So today we have Dr. Ameer Mohammed, who is a associate at the Princeton Plasma Physics Lab, and is also with, I guess in this realm, you're more with the, remind me, American Physical Society?
Yes.
Okay, I was trying to remember what APS, that's not a familiar acronym to me. So as a career mentor, and kind of much more of a, um, what's the word you might describe this? It's not technical, it's more of a, I guess, career mentorship or that kind of thing.
Yeah. This talk especially is more of a career talk.
Yep. So without any other introduction, take it away.
All right. Thank you. Thank you for having me. I'm very excited to be back, even if virtually. And so, yeah, today I'm going to be talking about careers post-graduation for kind of all degree types, undergrad, master's, and PhD. And so I just wanted to start just to kind of get a survey of the audience, everyone kind of in attendance of the talk, just kind of how many of you are undergrads, graduate students, postdocs, or faculty, and kind of current career goals, ideas for things that you'd want to do kind of post-graduation. Yeah, feel free to kind of answer, type in the chat, any of the above.
I'm an undergraduate.
Nice. Okay. One undergrad. Cool. What are your, I guess, any ideas of what you would like to do post-graduation?
I think I want to go into grad school, so I guess academia for a little bit. And then,
Awesome.
yeah.
Nice. Awesome. Yeah. I see Rose, your grad student, going to government. Awesome. Anyone else?
I'm an undergrad student too, and right now I'm thinking of getting a job in the private sector out of college, but I consider going for a master's also. Not quite sure which one yet.
Okay, cool. And just a quick question, since like this is a talk from like APS, I'm just curious what the different disciplines are, like what majors you guys are studying right now.
I'm studying electrical engineering.
Okay, cool.
I'm currently studying aerospace.
Nice. Awesome. Aerospace. Nice. Trent, I know, is also in aerospace. Cool. All right. Well, kind of that's good to know, and it'll help as we progress in the next few slides. So before I begin, all right. There we go. So I guess first I'll talk a little bit about me and kind of why I'm here. So I am a physicist by training. I got my bachelor's from the University of Maryland in May of 2018. Prior to that, I worked in a few different capacities through internships, research experiences. I kind of did various internships at NASA Goddard and Ames through 2014, 2017, through 2017, working on ground system and control system development for a few of the missions that they had going on there. And then I guess at NASA Ames in particular, I was an astrobiology intern looking into atmospheric plasma pressure jets and how they can be used to deactivate microbes, which was kind of a initially unusual project when I was kind of first starting it. I thought it didn't really have much to do with what I was studying in school and what I kind of wanted to do after school, but it turned out to be very, very useful in the long term because it was my first experience in a lab environment and also my first experience with plasma physics, which is what I ended up doing research in for my PhD. And so that kind of is just one example that I'll iterate kind of throughout the talk, which is that a lot of skills that like we pick up as we go through school and as we go through internships, research experiences are pretty translational, and they can, even though they're learned in one capacity, they can be easily applied to other roles as well. I also did some kind of undergrad research with University of Maryland's CMS collaboration at CERN. So that's like high energy physics research. I studied the radiation tolerance of scintillators using atomic physics modeling. And eventually, after all of that, I kind of started up at VT in the aerospace engineering department, specifically doing applied physics research into collisional plasma shocks in a laboratory setting. And I defended my PhD in November of last year and started at Princeton Plasma Physics Laboratory that same month, where I am presently working on the development of a real-time capable Thomson scattering diagnostic for an experiment called Wendelstein 7X, which is a stellarator that is based out in Germany. Around the same time, I also became an APS Career Mentoring Fellow, which is kind of why I'm here. And so to follow that thread, one question that like I usually get asked and that many students that are applying for jobs typically ask is that how different skills that are used in kind of prior experiences and previous jobs are relevant to their current job search or to jobs that they're now working post-graduation. And so this is just kind of a brief summary for me in particular of skills that I kind of picked up along the way and how they relate to what I'm working on now and how they are relevant to what I'm working on now. And so kind of through a lot of like my internships and research experiences prior to grad school, I learned a lot of kind of general skills such as software development with various different programming languages, C++, Python, Perl, Julia, MATLAB if you count that. Also kind of writing as well. And then in grad school, I learned a lot more kind of specialized skills that were relevant to my subfield, but also generally applicable to other studies as well. I learned spectroscopy, interferometry, high-speed imaging and photography, and then also just things with regards to presentations, like preparing manuscripts, attending conferences, things of that nature. And my current role right now is kind of a nice synthesis of all of the above in the sense that I am doing like a lot more software development now than I did in graduate school. So that's kind of a callback to some of the skills I picked up through my internships. But I'm also still very much in the plasma physics side of things, the experimental plasma physics side of things. Right now I'm working on a Thomson scattering system for a physics experiment that we have. But also there's always still things like writing manuscripts and proposals and simulations as well. So that's just all to say that kind of my like key takeaways from my kind of trajectory through undergrad and graduate school and how it led into my career now is that I think it's definitely useful to get involved in as many different projects as you can. In grad school, I know that can be a bit difficult just due to funding restrictions, project requirements, and things like that. But when I was applying to graduate school, one concern that I had at the time was that like I didn't necessarily have a consistent track record for internships in the sense that like I was consistently studying one specific thing summer after summer. Like a lot of my research experiences and internships were kind of all over the place in topics and skills, and that kind of concerned me a little bit when I was applying to grad school, but I've realized since that like it was very useful in the sense that I got to learn a lot of different skills and now can leverage them for whatever tasks I'm involved in working with. Another thing is just learn best coding practices as you go. That's been something that has been kind of invaluable in kind of preventing mistakes as you're working on research or projects or whatnot, and also just staying organized with your work as you go. And then the next thing, which I think is probably one of the most important, is to keep looking for opportunities to expand your network, but also try and keep in touch with your former mentors. Like if you have an internship, if you had an internship, maybe like a couple of summers ago, don't lose touch of your supervisor or your mentor. They're still kind of an invaluable resource if you're looking for jobs in the future, or if you want to kind of come back to that lab, that industry in the future as well. When I was applying for my postdoc, I had many of my former mentors write me letters of recommendation. So I definitely would not be here without their kind of support throughout all of that. But now let's kind of move on to the goals of this talk, now that the kind of expositionary material is covered. The primary goal for me is to provide a broad overview of career paths that are available to people with degrees in physics, but also people that have degrees in STEM in general. A lot of the statistics that are present within this talk are from surveys relevant to physics graduates, but a lot of the general concepts are quite applicable to other kind of degree holders as well. I also want to provide some resources that can potentially help with pursuing these career paths. And so to start, so I know I mentioned that I know you guys mentioned that there are a few undergraduates present. So I'll first talk about what you can do with just a bachelor's degree. And so for physics in particular, and for me especially, one misconception that I had when I was getting ready to apply into grad school was that grad school seemed like the next logical step for me as far as like what to do before getting a job. And for me, graduate school is definitely the right choice, but it's not the only choice. And I think that's important to emphasize, especially when surveying recent physics graduates, but also quite likely from other disciplines as well. We see that roughly half of graduates with a bachelor's degree tend to just jump right into the workforce. And if we look at the kind of division of sectors amongst that roughly 50%, we see that a lot of people end up going into the private sector, followed afterwards by colleges and universities, typically as like a research associate, high school teaching, followed then by national labs, active military. Other than that, we see that the remaining 50% is primarily composed of kind of graduate study in the field that they were awarded their bachelor's degree in, so kind of continuing down that academic journey, but also graduate study in fields that were not of physics or the degree that they were awarded. And I am technically in this kind of 16% here in the orange because I got my bachelor's in physics, but then went with the intention of applying to the aerospace engineering program at Virginia Tech. And so just focusing for a minute on the kind of field of employment for people who just jump straight into the workforce with the bachelor's, we see that there are a variety of different careers that are available to you. A lot of people who jump straight into the workforce in the private sector are still working in a capacity that involves solving technical problems and involves applying skills related to things that they learned over the course of their undergraduate studies. We see that a lot of physics majors, especially, they typically tend to go into studies like engineering and computer software, which makes sense because physics as an undergrad program is very heavily involved in things like coding and software development. And so that's very translational to computer science. It also makes sense that a lot of physicists would go into engineering, though the opposite is also true in the sense that a lot of engineers also take on physicist roles later on as well. And then there are also opportunities to kind of get jobs that also don't necessarily rely on kind of solving technical problems as much or as often. And that is definitely the case, and definitely a path forward if that's what you want out of a career outside of undergrad. And so as far as what common jobs would be for undergraduates who have just finished up and gotten their degree and entering the workforce, you can do a lot of things with a STEM degree and a physics degree as well. You can become a high school teacher. You can go into engineering, various types of engineering like systems, electrical, design, mechanical, all of which draw from different aspects of your undergraduate studies. As I mentioned before, coding and programming is definitely kind of a pathway into computer hardware and software related work. And then there's also research opportunities as well as at universities for those who are kind of have just finished up their bachelor's. There are like post-baccalaureate programs where you can do research, and then you can also as well go into things like business and finance. I do know some people who kind of finished up their degree in with the STEM major and then took those skills and applied them in the business and finance sector as well. So there are definitely options, and there are a lot of kind of varied career paths that you can take as someone who is kind of graduating with a bachelor's degree and entering the workforce. To highlight that a little bit, there's a few kind of profiles that I'll be kind of presenting throughout the course of this talk. And I have kind of a few for every degree type. So these are the profiles present for bachelor's degrees. And the first one is Jacqueline Benitez, who is a distance learning educator presently. And so she graduated with a physics degree and then found that she really enjoyed the teaching aspect of it and the kind of mentoring and educating the next generation of students and scientists. And so now she works in a capacity that involves facilitating science learning with kind of students all over the world. And then if we follow up on that, the next physicist profile that we have is Zara Hassani, who also graduated with a physics degree. And then she kind of started working at NIST and got a taste for research, but then really discovered that she wanted to work in computer science. And she's presently at Google working on back-end development. And so debugging and fixing issues before they make it to the front end. And so this is all just to emphasize that once you do have your degree and you decide to kind of pursue a career and enter the workforce, you can branch out and try different things and do kind of take different career paths. But that being said, the next question that we often get asked quite a bit is like, how much can you earn with a bachelor's degree in physics in this case, but also in kind of STEM and engineering in general? And so we've broken it down by sector here. And so keep in mind, this data is taken from new physics graduates from the classes of 2019 and 2020 combined. We have the salary on the top row presented as kind of a function, presented in kilobucks essentially. So $60 is $60,000 here. These box and whisker plots are presented such that the vertical lines are the median price, and then the shaded blue box contains the 25th to 75th percentile, with the horizontal lines showing the full range, excluding outliers, which are these kind of filled scatter points outside of the range of the plots. And so generally speaking, in a sense that it's kind of applicable to all STEM types, we see that the private sector is kind of presents the highest salary. The median salary is typically around 65 to 70 kilobucks. And the range can be fairly high for each of these. So it's definitely worth, as you're kind of applying to jobs, seeing what the salary range they specify in their job posting is. But as a general rule of thumb, the private sector typically has the highest median, followed by kind of private sector for non-STEM related fields, and then so on for like for civilian work, high school teaching work, active military, and college and university. But kind of next, I'll kind of talk about what you can do with a degree, with a master's degree. So we've covered what you can do if you enter the workforce with a bachelor's degree, though a lot of people do then proceed into graduate school for an MS. And so especially in the field of physics, and maybe this is applicable to other STEM disciplines as well, it's kind of assumed that when you start graduate school, the terminal degree would be a PhD. And like I mentioned, that's especially true for physics, where a lot of graduate students don't necessarily think of job options that are available if you just had an MS degree. And I think it's important to note that there are a lot of job opportunities with just a master's degree, both for physics, but also for all other STEM disciplines as well. And so in looking at this survey, we see that recent graduates with a master's degree, a lot of them go into the private sector. And so a majority actually go into the private sector, with 20% then finding jobs at colleges and universities, again, likely in some research capacity as a research associate. And so if we're, as I mentioned, I have kind of other physicist profiles, then these are for those who just went on to kind of proceed into the workforce with a master's degree. And so first one is Carl Markov Johnson, and he got an MS in physics after switching majors from engineering. And now he's currently the director of product development with a specialization in thin film technology. And then next off, there's Julia Shirtlet, who has also received an MS in physics. She found a job at NIST and now works as a thermodynamic metrology scientist. And so this is, again, just to highlight that there are many career options with a master's degree. Once you start grad school, you don't necessarily have to assume that you need a PhD in order to find a job. There are plenty of jobs available for those graduating with an MS degree. And then kind of moving on to the salary discussion once more, here we have a very similar plot to what was shown before, where we look at just the private sector and colleges and university. Once again, we see that the private sector for MS graduates tend to have a median salary in on the order of maybe 70 kilobucks, $70,000. And once again, the range can be quite high. So the upper bound of that range can be on the order of $130,000. And then for colleges and university, the median is a little less. It's on the order of maybe $45,000 to $50,000 a year. And once again, it's just important to note that these statistics are specified for physics graduates in particular. But generally speaking, they should be broadly translational to other STEM degrees as well. And then, so next up is kind of working after graduating with a PhD, which is what I did and what I imagine a lot of other students in the AOE department and the Space AV department are interested in as well. And so when I was looking for jobs after towards the end of my PhD, I was looking for postdoc positions because that was, again, maybe an initial misconception that I had, which was that a postdoc position seemed like the best kind of move after a PhD in my field. And for me, it was. I'm happy in my current position, but again, it's just important to note that there are other options. Like a postdoc is it should not be considered the default path after a PhD, and there are other kind of paths available to you depending on what you would like out of a career after graduate school. In particular, we see that about half of newly graduated PhDs do tend to go into the private sector for permanent positions. And this is important to note because postdocs are typically contract-based positions. They typically have an assigned length of 1 to 3 years. Now, depending on where you're employed and who you're working for, there can be the prospect of a more permanent position after your postdoc. But it's just important to note that they're designed in mind to be contract positions. And so if you would like something that is more permanent, there are options available to graduates with a PhD. And in fact, lots of recent graduates do find potentially permanent positions, a lot of which are typically in the private sector. And so if we focus just on that for a minute, of the kind of graduates who do go into the private sector, we see that once again, it's quite varied, which is just to reiterate kind of my initial point, which is that like when it comes to like multidisciplinary work or STEM related work, a lot of skills are translational to other fields and other jobs. We see that with regards to physicists, maybe only roughly 20% of physics PhDs who do go into permanent positions. work in a physics capacity. The rest are kind of distributed amongst other fields like computer, software, hardware, engineering, data science, business. And so it really, like, this is just to show that there are options for whatever you would like to do post PhD if you are interested in a more permanent position. If you would like to kind of keep on working in physics with the PhD or in whatever STEM discipline you're awarded your degree in, there will likely be jobs available that meet that criteria for you. But if you would also like to branch out and try other things and apply those skills that you learned from your research and from your degree to other fields, there is also plenty of opportunities available for you to do that as well. And so once again, common jobs of those who graduate with physics PhDs, but again, also translational to other STEM degrees or various types of engineering, education, especially applied scientists, quantum, so a lot of quantum computing, which is a very, very big thing right now, and then a lot of research and development. So like research associates, research engineers, research scientists. There are a lot of job titles that one can get and one can apply for after having a PhD. And so next up on the physicist profiles that I'm showing are Ramon Bartholomew, who is a physics PhD who decided to go the academia route. So he, during his PhD, he also became interested in issues contributing to the lack of diversity in physics and STEM. And so right now he's an assistant professor, but he also has a focus and an interest on equity and inclusion in the field, which is a very kind of important topic. And he is kind of one example of kind of graduating with a PhD and going down the academic route. But as mentioned previously, there are other paths that one can take. And so next up is Neha Pakari, who is now a manager process engineer. And so once again, she got a PhD. And then now she is working at Amazon, where she's working on automation and improvements for self-service software. And so this is kind of an example of having a PhD and going more the industry route. And then lastly, there is Jan Klinner, who is a director of research. So he got his PhD and wanted to kind of continue on with industrial research on plasma physics, acousto-electro-optics, laser material interactions. And so that's what he does. And these three physicist profiles are just meant to highlight, along with all the others for all the other degree types that I've mentioned, that it's no matter your degree and no matter what path you decide to take, there are ways to have kind of thriving careers after school. And as seen from all of these examples, all of these individuals took different paths that ended up working out very well for them. And then next up is, again, the salary discussion for a PhD. This time we see that the private sector, again, typically tends to have the highest median pay for those who graduate with a PhD and enter in the workforce. We see this time that the median is on the order of $120,000 to $130,000. We do see that postdocs typically sit within that $50,000 to $100,000 range over here. With postdocs, you can become a postdoc at a government lab or you can become a postdoc at a university. I am currently doing the government lab route where I'm at Princeton Plasma Physics Laboratory, which is a DOE national lab. And so we do see that for government lab postdocs, the median salary can tend to be a little higher, which is just worth noting. And so, yeah, again, just to reiterate, there are lots of jobs out there. They all pay well. And really when it comes down to looking for a career after school, it's just important to kind of consider what you value out of a career and what you would like out of a career. And then hopefully these kind of statistics and these kind of charts have emphasized that there is not necessarily just one option for you. There are multiple paths that you can pursue. That being said, though, it is important to talk about the kind of employment sector dynamics and specifically the supply and demand right now. And so this slide is tailored specifically for those who are looking into going into academia, which is basically a chart that shows the total number of faculty hired by physics departments across the country as a function of time. So we're looking at a survey taken from 2002 to 2016. And we see that on average, if we're looking at 2010 onwards, the kind of number of tenure track hires is on the order of like maybe 250 to 300 or so. That being said, the number of graduate students and newly graduated PhDs looking for academic jobs can be on the order of like 1,600 annually. And so that's just meant to show the reality of the situation when applying for an academic job, which is that there is kind of a supply and demand issue at the moment, which is that there are kind of more graduates with the PhDs than there are jobs available, which is not meant to discourage anyone by any means, but it's just also important to kind of keep in mind. That being said, as we look at the industry demand over time, we see that the industry demand has been fairly constant year after year, and with the kind of percentage of PhDs employed in the private sector every year staying essentially the same. And so if you are interested in going into industry after your PhD, there are definitely more than enough jobs available that can accommodate your interests and what you would want out of a career post PhD. The next thing that I wanted to mention, which I had not necessarily considered while I was in graduate school, was that whatever path you choose after graduating, you can always decide to kind of change it up further down the line within your career if you would like. And that's not necessarily something I had been actively considering at the time, but it's just important to note that there are plenty of people who do that. So there are, if we look at a survey taken of doctoral recipients between 2001 and 2013, we see that within a certain amount of time after receiving their degree, like a certain percentage of them kind of work either in education, business, or government. And then if we survey them roughly 5 to 9 years later, we see that the percentages have shifted ever so slightly. And that's just to emphasize that kind of it's just good to know that you can always kind of change course over the course of your career if that is something you would like to do. It is possible, and plenty of people do that. So when it comes down to it, especially when graduating with a PhD, a big question that a lot of people asked, and I certainly asked as I was kind of applying to jobs and considering job options, which was kind of what is better, academia, industry, or national labs? And I, after kind of doing some research and being a part of the APS Career Mentoring Fellowship for a while, it's important to note that that there is no kind of concrete answer of which is better. There is only kind of an answer of which is better for you based off of your values and what you want to achieve after you graduate. And so if you're specifically for academia can offer you more control over your research. If you are kind of hired as a professor, you have the ability to kind of direct your own lab. You can apply for grants. You can determine what problems you're interested in and what problems you would like to study within your lab. You can also get flexible working hours as a result of that. And especially as a professor, you can mentor the next generation of physicists, of students. It really offers kind of the opportunity to teach and mentor. And if that's something you really value out of a job, then academia could be a great potential path for you. if you're interested in industry, it's important to note that industry, just based off of the statistics that we've seen so far, tends to offer kind of a higher median pay compared to other sectors. Typically, the work-life balance is pretty good. For roughly, employees typically report having that kind of 40-hour work week. And because of the demand for industry being relatively consistent year to year, it could potentially offer more options for where you would like to live and where you would like to settle down. Now, next is kind of national labs, because as I mentioned, you can be a postdoc in academia, or you can do a postdoc in a national lab, and many postdocs at national labs do end up becoming scientists at these national labs. National labs are typically in the middle of the pay scale, and compared to academia and industry, they have mid to high pay. They typically also report pretty good work-life balance within that kind of 40-hour work week. And kind of, it's just important to note that at a national lab, you will have some control over your research, maybe not to the degree that you would if you were in charge of your own lab at a university as a professor. But you will have some control over research and over what problems you would like to solve. And so this is just to kind of give a general overview of what a career along each of these paths could offer. And so as you're graduating and looking for careers, it's just important to keep in mind whether you value one thing over the other. If you value having more flexible working hours and being able to mentor and teach, then academia could be a great place for you. If you value having kind of higher pay and better work-life balance, then maybe industry could be good for you. There is no kind of concrete answer to the question of like which one is better. I think all of them have their pros and cons, and it's important to kind of take them into consideration as you're looking for jobs and applying for jobs. All right. That being said, as long as you do pick a job that does kind of align with your values of what you want out of your career, regardless of sector, we do see that like people are fairly satisfied with their careers. A lot of people who graduate with a PhD and end up working in academia, private sector, or government, fairly equally in equal proportions report that they think that they've been well utilized in their role. They think that they find it professionally challenging, and they think that the kind of their backgrounds in their graduate studies has prepared them well for this role. So again, this is just to highlight that there is like, regardless of which path you take, there are plenty of opportunities, and as long as you're choosing a job that aligns with your values of what you would want outside of school, you will typically find yourself satisfied and content with the work that you will be doing. So next up is for kind of the students who are close to graduating or considering jobs and applying for jobs, is kind of how do you start preparing for careers post-school. A few things that are useful to do is just to, one, perform a detailed self-assessment. So as you're kind of going through your courses, as you're kind of going through your research and or internships, maybe take note about what you're good at doing, what you enjoy doing, what you value spending your time on. Reflect on how you best work. Do you prefer to work more collaboratively in a group? Do you like working independently? Are you goal-oriented? Another thing to keep in mind is that it's useful to also keep a career notebook or a document. You can track skills that you've developed over the course of your work that you kind of would like to further develop in careers outside of school. One thing that I think is really important to note, is to note when you are happiest and when you are the least happy in your role as a student. That will help you kind of funnel down what potential jobs would be best for you and what capacities you'll be happiest working in. It's also important to know what's important to you. So as I was talking about with regards to values, what you really value out of a job and what are non-negotiables for you when you're applying for jobs. For example, is it work-life balance? Is it money? Is it location? Your answers to all of these questions will definitely will definitely help you determine what sector is best for you to pursue. Next is just kind of, as I mentioned, tracking insights and skills, documenting skills, specifically technical and non-technical skills. This is really important for resumes as well, and this will streamline the resume writing process as you're tailoring resumes to different jobs that you're applying to over the course of your application process. And so I mentioned earlier when I was talking about some of the takeaways I had from kind of going through graduate school and going through all of my internship and research opportunities, I think it's important to expand your network and also stay in touch with your network. So just to follow up on that thread, yes, building your network is very important. Join LinkedIn, connect with others. Attend conferences is a big thing, especially if you are a graduate student. Definitely attend conferences so you can meet other individuals within your field, talk to them about what they did after they finished up school to get a sense of what the different career paths available to you within your subfield are. Attending alumni mixers, career fairs are all very helpful. Volunteering is a big thing. If there are volunteering opportunities for you, it can help. First off, it's just useful to kind of mentor and help the next generation of students, of scientists. It's also very useful for you as a continuous student of the field to help reinforce your fundamentals. But also through volunteering, you may discover certain things that you really like that you wouldn't have otherwise discovered. There are plenty of people who discovered that they have a passion for science communication and education through volunteer activities, and then that is kind of what the path that they followed after finishing up school, and they're quite happy and content with that. And so volunteering is definitely a big thing. If there are opportunities for you to volunteer, I definitely recommend doing so. Finding internships. So there are plenty of internship listings on careers.aps.org. It's important to note that while APS is kind of, while APS in this talk is tailored for the physicist in mind, a lot of these internships are likely still available to other STEM disciplines as well, as long as you meet the kind of requirements for the skills that would be involved in these internships. I definitely recommend checking it out and maybe applying if you see any that would be interesting to you. Connecting with academic mentors is definitely very important. APS has a national mentoring community, and it's specifically designed for Black, Indigenous, and Hispanic physicist students. You can find that at aps.org/NMC if that's of interest to you. This program provides you with access to academic mentors all around the world. And so that can be a very useful resource that you guys can kind of leverage as you proceed in your careers. It's also worth noting that specifically if you attend any APS programs, that emergency funding is available for any registered mentees. And so that's maybe something to keep in mind if you're a member of APS and you would like to attend something like a conference or a mixer. It may be possible to get emergency funding to attend these events and expand your network, should that be something that you would like to do. And then lastly, in addition to connecting with academic mentors, I think it's important to also find industry mentors, especially if you are interested in pursuing industry after you finish up school. APS has a program called the Impact Program, which is where you can be paired with industry mentors. And then, of course, it may also be very useful to ask faculty members to connect you with industry professionals or past students who have decided to go into industry. On the topic of connecting with past students, I think one invaluable resource when you begin your job search process is to kind of attend informational interviews. So you can reach out to past students, you can reach out to other different contacts and just ask them for a quick 30-minute chat. You can kind of find out a little bit more about their career path, what their typical work day looks like, what parts of the job they like and dislike, and also just get kind of one-on-one feedback on how to prepare for a similar career path if that is something that you're interested in. So if you are looking for jobs currently, definitely look into the possibility of scheduling informational interviews with different contacts. And then I just wanted to highlight a few other resources that APS provides. So we do have free webinars on success in industry careers, career exploration, public engagements, development for international physicists and international students that are based in the US presently, as well as development for undergraduate students. And all of that can be found under the aps.org/webinars, hyperlink below. And so with that in mind, here are just a few other resources that APS provides. And so I can put the link for all of these in the chat towards the end of this talk here. But again, all of them can provide kind of advice from professionals in the field, lists of common job titles and like postdoc opportunities that are available or that will be available in the future, as well as just general tips with resume, cover letters, help with interviewing, things of that nature. And again, I'll put the links for all of these in the chat later on. So the last big thing that I did want to mention is that while this talk has been kind of focused on talking about what you can do after you finish up school and are looking to start working, I have not yet covered non-US citizens. And I think it's very important to note that the APS is aware of the fact that there are recent policies that can unfortunately hinder international physicists and international STEM students' employment in the United States. And so with that in mind, I just wanted to provide a few resources that may be of interest and of use to international students and international students looking to enter the workforce. APS does have an international affairs website, as well as an Office of Government Affairs website, links for both of which are right here. And the APS Government Affairs Office is actively advocating for better policies for international students to also help make it easier for them to find jobs after they finish up their schooling. If you are an international student, I definitely recommend the APS Impact Program, which is a kind of program that can pair you with mentors, and they are quite passionate and intentional about trying to pair you with mentors from non-US backgrounds that can maybe help provide some additional perspective and information on kind of how to facilitate the job search process. Additionally, APS has webinar series on career development for international physicists and students, also at the aps.org/webinars site, as well as some additional employment resources for international students available at this last link below. And so lastly, that kind of more or less concludes the gist of my talk. I hope it was informative as far as potential career paths for those of you who are considering your options after you finish up school. I hope it has given you a little bit more insight onto maybe some of the differences associated with careers in industry, academia, and national labs. Lastly, I just wanted to mention that if you are interested in becoming an APS member, I definitely recommend it. It'll help you staying current with research publications if you are interested in different types of physics research that is being done. It's definitely a great way to present your work and network with potential employers, both at APS meetings, but also kind of smaller scale kind of meetups and webinars that frequently occur through APS. It also allows you to get involved with grassroots advocacy on important issues like immigration, research funding, and more. And it also just connects you with a very nice community of other students, early and mid-career scientists that you can leverage and you can talk to and get more information on as you're proceeding through your academic careers and as you decide to enter the workforce. And so with that, I will kind of conclude the talk. Thanks for having me. I hope this was helpful to those who are getting ready to start the job search process. If there are any questions, I am happy to answer them. Yeah, I guess I will open up to you guys.
Being maybe one of the non-students here, I do actually have a question for you.
Sure.
At least two things. There was one, there was one slide towards the end there that was saying, it was the last bullet, so it went by pretty fast, about don't ask for a job.
Oh, yes.
So remind me, what was the context for that? Because I have a bit of a comment, I guess.
Yeah, let me just bring that up again for you. The context of that slide though was for the kind of informational interviews. So that is just kind of a recommendation that if you're kind of looking just for information on potential job avenues in your field of interest, to kind of have the intention for that meeting just to be about gaining information for the different types of career paths rather than asking for a job up front.
Yeah, I say that's more with like a mentor or something like that, right?
Yeah.
Yeah, I say the context is, so I was listening in, I don't know if you were a part of it or heard that Space BT had a new frontiers in space kind of workforce kind of panel discussions, and one thing that I heard about that is maybe, so in this context but in the context of a lot of times they would have they're talking about students who are doing internships or even I think something more informal like that, where maybe working on a project, right? In BCE we have the MPE projects and things like that, that basically the students just never asked about, not straight, there's a better way to do it, but like they basically just never asked about employment opportunities kind of. Yeah, we've got lots of them. So that was one thing that kind of, so in the right context.
Yes. Yeah, this is definitely not meant to discourage anyone from asking for opportunities, for sure. But yeah, again, just in the context of like a purely informational interview, where the kind of goal is just to get kind of information on potential careers. Yeah, just the recommendation from APS was just not use that more for an information session rather than asking for opportunities.
Yeah.
I just wanted to make a quick comment on just related to that, because I had helped organize that space, the conference yesterday, is that I think when they were talking about the students who had, let's say, worked on a power, on a project for a whole semester or a year, and the company knew them, and so in those kind of cases, it was okay to ask, but I totally agree about if it's an informational meeting, it puts people under pressure if you ask them and then. And Ameer, I have to say, I wanted to meet you because my name starts with A and then it's Mohammed spelled the same way. So now if I get email for you, I know where it can go.
Great. Yeah, thank you. It's nice to meet you.
Same here.
Yes, I think in one case I've had to switch that up, or I've seen that kind of mix up. But the other thing that I was going to ask a little bit is, it was basically, I thought about the question and you put it on the slide, so it was well timed, but about the networking part of all of this. Can you kind of speak to your experience, at least, and how maybe networking played a role in going from a physics degree undergrad to a engineering degree graduate, or or graduating with that PhD and then to your current position, how networking may have played a role there?
Sure. So the kind of big thing was that through my research experiences and internship experiences in undergrad, I was able to get a lot of letters of recommendations for graduate school applications that definitely helps. That's one of the reasons I definitely recommend kind of keeping in contact with your old mentors from different opportunities and different experiences as you go. And so when it came to applying for a postdoc, definitely the thing that helped with networking was attending conferences for me. So for plasma physicists, there's an annual conference every fall that kind of gathers plasma physicists from all around the country and puts them all in one little room together to talk about our research. And there's also job fairs. And so that was a really, really invaluable networking opportunity for me in particular, because I got to talk about what different types of job opportunities were like both in industry, in kind of national labs and academia. So that helped as I was kind of deciding what I wanted to do post PhD. And it was also where I met a lot of other people doing research similar to mine or doing research that I was interested in. And so those were people that I was able to kind of follow up on later on as I was going through the interview process to get kind of feedback, support, mentorship from. And yeah, I think the conferences in general were a very big part of helping me to get my postdoc now.
Oh yeah, thank you. Other questions from around? Other questions online? I think that there's 2 chat messages, but I think that's from earlier.
Yeah.
Yep. Oh, yep, yep.
Ameer, thank you.
Yeah, thank you, Debbie.
A lot of good information there.
Yes, sir. Yeah, with that, sort of a round of applause, I guess, here in the room when we're online. Then this is, I say we're basically a week out from reading day. So it'll be the end of Space at DT's seminars for this semester, and we'll start things up again in the fall. So thanks to Mohammed, thanks Ameer rather, sorry, and thanks to all the speakers we've had so far this year, kind of thing, and everybody attending, whatnot. Feel free to please grab a cookie before you leave. And yeah, thank you for the attendance online. We'll conclude there, and we'll see you, I guess, in several months. Everybody have a good summer, and see you back in the fall, hopefully.